Okay, so this is my quick review on lines. This is part 2 of this series. So I'm going to talk about slopes, horizontal and vertical lines, and equations of lines. So we're just going to get right to it. So we're going to talk about slopes. Okay, so when we talk about slopes, we're talking about the steepness of a line. There are a couple different ways on how you can find slopes. So one way that you can determine a slope is just from straight up having the line in front of you, and then you can figure it out. So one thing we talked about in the last video is that the slope is represented by the letter M, and we usually think of it as rise over run. So if you have just a random graph like we have here, what you can do is you can really figure this out just from the graph. So what I'm going to do is I'm going to examine this graph, and I have to just choose whatever points seem like they're the most obvious to me. So in looking at this, I see -1 here and -3 here. So this point right here, this one I can easily make out. And then the other point that looks like I can easily see it is this one right here. So this is the point 0, -1. Okay, so now that I've found 2 points that I can easily see, what I can do now is I can compute this rise over run. So the rise is, so we always want to start, by the way, we always want to go from the left to the right. So to get from this point on the left to this point on the right, what I'm going to do is I'm going to go up. So here I am at -3, so I'm going to go up 1 to -2. So here's 1, and then here's 2. So I've gone up 2. And then I'm going to go over 1. So my rise is up 2, so this is 1, 2. And then my run was this way, my run was 1. So this just equals 2. Okay, so I have a second one here. So once again, I would recommend that you just pause the video here and try this on your own and then hit play when you think you've got it. So this point here, I can really easily tell this is 0, 2. This point here, this is 3, 0. Okay, so remember, it's going to be rise over run, and I start with the leftmost point. So in this case, this would be this point. So in this case, to get from this point to this point, I have to go down. So I go down 1, 2. So this is -2 for my rise, and then I'm going to go 1, 2, 3. So -2/3, oops, sorry about that, -2/3 would be my slope in this case. Okay, so that's one way that we can find the slope. There is also a formula to find slope between 2 points. So if I have 2 points, so we'll call them x1, y1 and x2, y2, this is the slope formula. So it's y2 minus y1 over x2 minus x1. So the big thing that I want to just impress upon you is that the points go together. So it doesn't actually matter which one you want to call your x1, y1 and your x2, y2. It's just that the points have to go together. So let's take a look at this. Let's say that I want to find the slope between these 2 points. So this formula is nice if you don't have the graph in front of you. So it doesn't matter which ones you want to call your x1, y1. I'm just going to call this first one x1, y1, and this second one x2 and y2. And so now I'm going to use that slope formula. So this is the slope formula that we need to use. Okay, so I have y2 minus y1. So I take this y coordinate minus that y coordinate. So 7 minus 5, and then this x coordinate minus this x coordinate. So this will be 2 minus 4. So I go ahead and I just compute all of this. So this is going to be 2 over -2. And what does this simplify to? This simplifies to -1. And so that would be the slope in this case. Now, here's the thing. If I chose a different order for these points, so if I called this x2, y2, and this one x1, x1, y1, so if I did that, so let me just get rid of all of this for a moment. So if I went that route, would that change anything? So let's see. In this case, then I'd take my y2 minus my y1. So this would be 5 minus 7. And then my x2 minus my x1. So this would be 4 minus 2. So this would be -2 over 2. So this equals -1. So it still gets me to the same thing, right? So it doesn't matter which order that you want to put the points in, and that's something that you can think about. What really matters though is that like So the coordinates have to stay together, right? So the 5 and the 4, they come first. So, right, they stay together. And then the 2 and the 7, you see how like they stay together too. So that's kind of the idea. Like they stay within that column or whatever in the formula. Okay, so I have another one here. So I would just recommend that maybe you pause here and give this a try and then hit play when you're ready. Okay, so like I said, it doesn't matter which one you want to call your x1, y1, and your x2, y2. I'll just go ahead and call this x1, y1, x2, y2. So if I set this up, so I'm going to take y2 minus y1, so I'll take 7 minus 3, and then x2 minus x1, so that's going to be negative 4 minus negative 1. Now, in this case, a negative and a negative will create a positive, so this will equal 4 over negative 3. And by the way, with a negative in the bottom, so just a little fact here. Sometimes I get questions about like, oh, but there's a negative in the denominator. So the way that negatives work with fractions, it doesn't matter if the negative's in the top or in the bottom. It's viewed the same mathematically. So that's why a lot of times like we just then reset it so that it's like right in the middle of that fraction, but all three of these things are equivalent. So in this case, I would rewrite this then as just negative 4 over 3, and so it would be down 4 and over 3. Okay, so I have two more now, and this actually is a great segue to the next topic in this video. So go ahead, pause here. There's something weird that happens, so figure out what's weird and then hit play when you think you've found it. Okay, so I'm going to take 7 minus 5 over 4 minus 4, and I get 2 over 0. Okay, so I get 2 over 0. So what does that equal? So a lot of people actually forget this. So you can't divide by 0. This is actually called undefined. And so what does that mean? Does that mean that we made a mistake? Well, if I just really quickly graph this, so let me just set up a little graph here. So here's 1, 2, 3, 4. So here, let's say this is 4, 5, and then let's say this is 4, 7. Okay, so if I connect these 2 points, you'll notice that this is a vertical line. And so with a vertical line, so let's think about this, rise over run. So the rise of this, we can count however many. So right, this was up 1, 2 points. But what was the run? So the run for a vertical line, it has no run, right? It is actually 0. And so the calculation of 2 divided by 0 is undefined, and so that is what it is. So every vertical line has a slope that is undefined. That's actually what that means. Okay, so let's contrast that to the next example then. Once again, just pause, figure out what's weird about it, and hit play when you're ready. So now I'm going to take 6 minus 6 over 5 minus 3 to get 0 over 2. Now, 0 divided by anything is just equal to 0. So that's fine. But what does this mean? So this is also kind of an interesting result, right? So here's 3, 6, and here's 5, 6. So I'm kind of just approximating these. Okay, so I've connected them. So this is a horizontal line. And again, so with a horizontal line, so if you just think about this from the rise over run argument, what is the rise? So it's a horizontal line, so it has no rise, right? It has a 0 rise. So all horizontal lines have a slope of 0. And so like I said, this is a great segue into the next topic, which is vertical and horizontal lines. So vertical and horizontal lines, they look a little funny in terms of how their equations are. So for a vertical line has the format x equals a, where a can be any number. And we just talked about this, right? So the slope of every vertical line, this is going to be undefined. And it's because, so here's a vertical line, right? You can have whatever rise you want between 2 points, but the run is always 0. And since we're dividing by 0, that's what makes it undefined. But yeah, so for every vertical line, they always have this kind of funky looking format of just x equals some number. And then for a horizontal line, so a horizontal line has the format y equals b, where b can be any number. This one maybe could be a little easier to remember because the b also will be the y-intercept, so you might remember that from the slope-intercept equation. And the slope of every horizontal line is going to be 0 because it's going to be a 0 rise, and then whatever run you have between 2 points. So that is vertical and horizontal lines. Those will come up from time to time. I do a couple of those in some of my other example videos, but that's kind of a crash course reminder of them. So now what I want to do is I want to pivot and I want to talk about equations of lines. So let's talk about just some classic equation of lines problems. So one of the things that can come up is something like a line goes through a point, so 4, 5 in this case, and has the slope m equals -2. And I want to have this in slope-intercept form. Now, in my previous video, part 1 of this series, I talked about these 3 forms of a line. So what this equation is asking for is for us to give an answer in slope-intercept form that ultimately would be a line that captures this information. So there's a couple different ways on how you can do this, but I happen to think that the easiest way to do this is to use the point slope form whenever you're writing equations of lines. Because the nice thing about the point slope form is that the point slope form allows you to input any point, right? So you have a slope and then any point, x1, y1, and you can just plug it straight into the point slope form. And then from there, then you can arrange this to get this into slope-intercept form. So let me bring up the point slope form. So I've got my handy dandy formula here. And so what I'm going to do just to start writing this equation is I'm just going to input all the information that I have. So I've got this point here, that's going to go into my x1 and my y1, and then I've got this slope, so that's going to go into where the slope is. So let's fill this in. So the y coordinate we just said was 5, so this will become y minus 5. The slope was -2, so that will take place of m, and then I'll input this 4 in. Okay, so now I've got this in the point slope form, and I can pretty easily now get this into slope-intercept form. So just to remind you, slope-intercept form really is this y equals format. So to finish this, all I need to do is solve this for y. So to solve this for y, let me make a little space here. Okay, so first thing, I've got to distribute that -2. So this will be, let's see, -2x plus 8. And then to finish getting the y by itself, I can just add the 5 to each side. So I have y equals -2x plus 13. So that will be my final answer in this case. And so now that is an equation that will contain the point 4, 5 and the slope -2. However, that equation now is in slope-intercept form. Okay, so let's try another one like that. I would suggest that you pause here and try this one on your own, and then hit play when you think you've got it. Okay, so once again, I'm going to use that point slope form. So I've just written the equation out for us so we can easily reference it. So this is going to become y minus 3 equals -1/2 times x minus -2. Okay, so now I can work on solving this for y. So of course I've got this negative and this negative, so this whole thing will become positive. And then I can go ahead and distribute this -1/2 x. And -1/2 times 2, what is 1/2 of 2? That's just 1, so this is going to be -1. And then to finish this, I'll add 3 to both sides, so my final answer then will be -1/2 x plus 2. Okay, so that's one type of writing equations of lines. The other type that I'm going to cover here, and I should say that I haven't covered all types, but I've covered some big ones. So the other type is writing the equation of a line through 2 points. So to write the equation of a line in 2 points, so there's really 2 things that you need for a line. For any line, a line needs a slope and it needs a point. Those are the 2 things you need to figure out the equation for any line. And so what you'll notice here, right, is I have 2 points but no slope. However, since I know those 2 points, I can determine the slope. So the first thing that I'm going to want to do then is I'm going to want to determine the slope between these 2 points. So let's bring out that slope formula of that y2 minus y1 over x2 minus x1. Okay, so if I plug these points in, this is going to give me 5 minus 3, so those are my y coordinates, and then 3 minus 2, those are my x coordinates. And this will become 2 over 1, so this will equal 2. Okay, so now we need to choose either point that we want and then use the slope to find the equation of the line. So it doesn't matter which one, you will get the same answer either way. So just choose the one that looks like it's going to be easier to compute with. So I'm going to use 2, 3. So let me get some space. So I've chosen to use the point 2, 3 and the slope 2. And so now I'm going to plug this into my point slope form. So here's all that information. And now I want to write this in slope intercept form. So a lot of times when you're asked to do these, you just want to get in the habit of writing these in slope intercept form. So this will be 2x minus 4. Add 3 to both sides. This is going to be 2x minus 1. And so there is the equation of your line in slope intercept form. Okay, so I have one more example like this here. So I have these 2 points. Strongly recommend that you pause the video here, give this one a try, and then hit play when you think you've got it. Okay, so first let's find the slope. So let's see, I'm going to take 5 minus negative 3. So that's going to give me really 5 plus 3. And then negative 4 minus negative 2. So that'll give me negative 4 plus 2. So this will become 8 over negative 2. So this slope will simplify to negative 4. Now I can choose either point that I want, and I'd rather choose the point that has more positive things in it. So I'm going to choose this as my point. If you chose the other point, that's totally fine. You just want to, you should get the same answer as I did. So let's see. I've got y minus 5 now equals the slope of negative 4 times x minus negative 4. And so again, these are going to become positives. So now to solve this, I am going to distribute that negative 4 and then add the 5 to both sides. So I get y equals negative 4x minus 11. Now, as a reminder, you can't master math just by watching YouTube videos. You do have to practice it if you need to really learn this. So this review video also comes with additional practice problems, and so that includes a PDF, an answer key, plus a video just showing you how to work any of the problems. So if you're trying to master this, I recommend that you check out that practice problem set. So you can find that for free at divideandconquermath.com, and then just go to the review section. And by the way, my review series has a lot of other topics in it, not just lines, and each topic works just like this. So it comes with some refresher videos, practice problem videos, answer keys, everything you could really need to quickly refresh a topic. So just go to divideandconquermath.com. The review section will have everything that you need for free. If you found this helpful, I would love it if you'd hit that like button, and otherwise hit the subscribe button, and I will talk to you guys next time. Bye!